Hey guys, Mr. Backwork here. In this video we're going to look at using integer exponents. When we're talking about exponents, exponential notation is something that's used to shorten a product multiplication of a bunch of repeated factors. So if we were taking like 3 times 3 times 3 times 3, there's a shorter way to write that. So what we would do is we would take all of those 3's and combine them to just be 3 to the 4th power. So in general, what we can say is if we're multiplying some number together, so let's say we're taking a times a whole bunch more a's, what we can do is shorten that to be a to the nth power, however many factors there are. That a value is called the base, and then that number that we put on the base is called the power or the exponent. So we would read this as a to the nth power. In this example, we're going to look at identifying the base of a couple exponential expressions, and they look very similar to each other, but there's a very slight difference. In the first one, that -3 is inside of parentheses, and then we have that 5 on it. So we're raising the entire -3 term to the 5th power, which makes the -3 the base. Now b is similar, except the -3 is not inside of parentheses. So what we have to actually be careful of is, technically this would be like taking -1 times 3 to the 5th power, having that hanging negative out in front. So really in this case we just have 3 as our base. Now we're going to start taking a look at a few properties dealing with exponents. So let's say we had u being raised to the power of m, and then we were multiplying that by u being raised to the power of n. So we've got the same base here, and if you're multiplying things together with the same base, what you're allowed to do is add those exponents together. So we keep the base value the same. So we're still going to use u as the base, but we're going to add those exponents together, so m plus n. So if we had something like 5 to the 3rd times 5 to the 4th, we keep the base value the same, so we're going to keep the 5 the same, but we are going to add the exponents together. So that'll result in 5 to the 7th power. Now similarly, but a little bit different, if we were dividing, so taking u raised to the mth power divided by u to the nth power, and again it's very important that the base values are the same. What we can do here is keep the base the same, but since we're dividing this time, we're going to subtract the power. So we're going to take m minus n. So if we had 2 to the 7th power divided by 2 to the 4th power, we are going to keep the base the same, but we're going to subtract those powers. So that'll result in 2 to the 3rd power. Now 0 is a special power. If we take u and raise it to the 0 power, if we take any base number and raise it to the 0 power, the answer we get is always going to be 1. So if we take 4 to the 0 power, we get 1. If we were to take 8 and raise it to the 0 power, we'd get 1. If we took 1,000,000 and raised it to the 0 power, we still get 1. Our next property deals with negative exponents. So if we have u being raised to the power of -m, what we're allowed to do is we can take that negative power and turn it into a positive power by using a reciprocal. So what we need to do here is we need to take 1 over u to the positive m power. So if we had something like y to the -3rd power, we can take that -3 power and make it into a positive 3 by doing the reciprocal of this, so making it 1 over y to the 3rd power. Just a few more properties to take a look at here. For our next property, what we're going to do is we're going to take u times v, but we're going to raise that entire expression to the mth power. What we're allowed to do here is we can actually take each individual base and raise it to the power of m. So we're going to take u to the mth power times v to the mth power. So if we had something like 2x being raised to the 5th power, we could rewrite that as 2 to the 5th power times x to the 5th power. Now technically, if we were simplifying this down as much as possible, we would want to figure out what 2 to the 5th power is. That happens to be 32. Now we can't really do x to the 5th power since we don't know what x is, so we would just leave that as x to the 5th. In our next property, let's say we have u being raised to the power of m, but then we want to raise that to another power. What we're going to do here is if we have a power raised to another power, we are going to add those exponents together. So we leave the base the same, but we are adding the m and the n values together. So if we have t cubed being raised to the fourth power, we're going to keep the base of t, but we're going to multiply those powers together, so 3 times 4, so we're going to end up with t to the power of 12. And our last property, we're going to take u and divide it by v, but this time we're going to raise all of that to the power of m. A lot like we had in property number 5, we're going to put that m power on each one of our bases, so this will turn into u to the m over v to the m. So if we had a over b, and we were raising that to the 7th power, what we can do with that is make that a to the 7th over b to the 7th. In this example, we're going to look at simplifying down some expressions that have exponents on them using all of those different properties. So here in our first example, we've got 2a times b cubed, all being multiplied by 5a squared times b to the 5th. So we're going to rearrange this just a little bit, and I'm going to look at the things that are like terms to begin with. So here we've got this 2 and this 5, and since we're multiplying these terms together, we're going to take the 2 times the 5, so that's going to be 10. Then, I'm going to change colors here, we've got a and a squared. Again, we're multiplying these together. This a doesn't have a power on it, so we should read that as an implied first power. If we're taking a to the first power times a to the second power, remember we said if we were multiplying like bases together, we would add those powers. So if we take a to the first power times a squared, we're going to get a to the third power. And then similarly, if we have b cubed times b to the 5th power, just like we did with the a's, we're going to add those exponents together. So we're going to get b to the 8th power. In our second example, it looks like we've got some dividing happening. So again, I'm going to focus on the things that are the same. So first, let's look at these u values in the front. So we've got u squared divided by u to the negative first. We're going to subtract those powers. So if we take this 2 power minus negative 1, we're going to get u to the 3rd power. And then if we look at these v's, we've got v to the negative 2nd divided by v cubed. So if we subtract those, we're going to get v to the negative 5th power. Now, typically, we don't want to write things out with negative exponents on them. So we're going to use another property here to rewrite this v to the negative 5th power. So really what we're going to have is u cubed times, remember we can take this negative power and turn it into a positive by doing the reciprocal. So I'm going to do 1 over v to the 5th power. And then to wrap this up, if we're multiplying fractions together, I can turn this u cubed into a fraction by putting it over 1. If we're multiplying fractions together, we multiply the stuff on top. So u cubed times 1 is still u cubed, and 1 times v to the 5th on bottom is just v to the 5th. Now in this last example, we've got x squared over 2 being raised to the negative 3rd power. And negative powers can be tricky to deal with. So what we're going to do is actually take this and turn this into a positive 3 power by doing the reciprocal. And the reciprocal means flip the fraction over. So if we flip that fraction over and make it say 2 over x squared, then that negative 3 power that was on the outside turns into a positive 3 power. And then what we're going to do with that positive 3 power, since we've got kind of 2 terms here, we've got a top term and a bottom term, we're going to put that 3 on each one of those. So that's going to be 2 cubed over x squared cubed. Now there is a little bit more simplifying that we can do here. 2 cubed is actually 8. And on the bottom we have a power being raised to another power, so we're going to multiply those together and get x to the 6th power. That's going to be it for this video. Thanks for watching.